So actually, this presentation sounds similar to the previous topic. Okay. This is about engineering again, but with a different pricing function. So how I plan this session is like I will be discussing through the paper, one of my paper. So there is no separate section for the paper discussion. So I will be explaining this concept with my own application. Okay, what is this B2B and operator? What is P2P and engineering? What is transaction? So this session is also about new pricing scheme. Introducing new pricing scheme. I have introduced two pricing schemes. Just the pricing logic, not pricing mechanism. Okay, this is already discussed. Nowadays, consumers are becoming prosumers, and prosumers are encouraged to participate in different utility programs such as DSM, or transact products. We already discussed what is DSM, what is demand response, what is transact products. So I have already covered what is P2G pricing. Okay, what is P2G pricing? Last time I told you because of the increasing number of the utilities are reducing their effective price significantly. You see, in instance, they withdraw this effective price because everybody started, integrating the renewables, and government doesn't have money to support it. Basically, this FIT price is introduced to support the small scale vehicles. Okay, nowadays all the people out there installing solar or wind, they are exploring power delivery and network engineering. It's difficult to manage. Okay, so that's why the government started increasing this effective price. Some people they withdraw. And we already discussed what is PV. So because of the price gap difference, because of the price difference between the retail price and the effective price, the government introducing the new concept. The public, whoever the stakeholders of utility company, they are introducing the new concept. We already discussed with one of the stakeholders of the utility operator and the participants. Here amongst the participants refers to both the consumer and prosumer. Operator job is to facilitate the energy trading by designing a new pricing balance. Okay, and he has to maintain the real-time balance between the demand and supply. Participants refers to the consumers or prosumer who are willing to participate in it. This is an architecture that I proposed. Okay, I think we already discussed once. Okay, this is a transactive energy commodity or a residential energy commodity. I will be calling it as a residential commodity where I am proposing this new pricing scheme in order to facilitate people energy to meet their individual needs. This is the architecture where a group of consumers are there and a group of prosumers are there. They are equipped with all types of smart appliances, hams, and smart meters. And they are having co-wire network as well as the type of data. All the smart meters are interconnected to the demo. So you may be confused with the demo. Demo you can imagine it as a third party or an aggregator or an agent. So in my vector, I call it as a transactive energy market operator who is part of the utility company. He can be a third party also. Okay, he can be part of distribution network or he can be a third party. Let us say you wanted to introduce this business model. You can build a company that facilitates this energy trading. You should have your own software and equipment to propose this idea to the government. Okay, so this fellow's objective is to facilitate energy trading and to maintain the real-time balance between the demand and generation. And what is the objective of the participant? Their objective is very simple. They wanted to optimize their energy consumption. Okay. So now in this architecture, all these agents will interrelate, negotiate, transact to make their individual object. As I told you, the individual object of the participant, the object of the participant is to optimize the objective of the element is to facilitate the energy trading, and in a way, utility is a passive. He will just observe how much energy you are, buying, how much energy you are exporting. Based on the daily charge or giving service. Okay, so this is the pricing mechanism that I use. This is the simplest pricing mechanism. What is this mechanism called? Last time we discussed how this entire architecture and algorithm works. Initially, each and every participant will prepare their demand, day ahead generation. That information is broadcasted or transmitted to the agent or an aggregator. Now, aggregator receives the demand and generation. Now, he has to decide the pricing mechanism at what price they have to trade. This is the very simplest algorithm. Okay, so what I do is based on the net demand, the sign of net demand, they are classified into exporters and importers. The participants are classified into exporters group and importers. Exporters are means sellers. Importers are means buyers. And they are further prioritized. They are prioritized based on the offer price and the bidding price. This is somewhat related to auctions. Okay. So now the buyer wants to buy some amount of energy at certain price, certain reservation price. Now the seller is there, he is offering certain price. Okay, he has his own reservation price at which he wants to sell. The buyer at which he wants to buy. So based on that, they are prioritized. This is the seller's group, this is buyer's group, and further they are prioritized. High priority is given to the seller whose offering price is less. The person who is offering at a lower price is given high priority, which is exactly opposite side. The buyer with the highest buying price is given high priority. They are further prioritized based on the bidding and offering price. Now, how you are closing it? So they will be trading between the high priority seller to the high priority buyer. So what is the price of the deal? Price of the deal we have taken select simplest one, average price. Let's say I have an excess energy. I am ready to sell at 1 euro, 1 euro, 1 rupee per unit. 1 rupee per unit. The other person is a bidder, the buyer. He is ready to buy at 3 rupees. Now the buyer, the trading price is that just simple average. This is the simplest one. There is no further simplification. Just 1 plus, let's say 3. 1 plus 3 by 2, 2 rupees. Okay, that is the trade. Let us say this fellow has 4 units at some reservation price. And this fellow, he wants to buy 2 units at some reservation price. Now this fellow is trading first with this guy and he has an excess energy. And that fellow will immediately trade with another high priority buyer. This is how the logic will continue. Okay, the high priority exporter will be exporting for the high priority importer. This is the simplest logic. There is no complications in it. The simple thing, the price of the deal. The price of the deal is just an average price between the buyers and sellers. So this is another pricing mechanism that I proposed. This is a periodic double auction. Okay, what is this periodic double auction? Now we should know what is an action mechanism. You know actions. What is an action? Okay, there are group of buyers are there, group of sellers are there, and they have their own reservation prices at which they wanted to buy, at which they wanted to sell. There are different types of auctions: English auction, Dutch auction, single-sided auction, double-minded auction. There are so many types of auction. One of the auction is double auction. It is not that I introduced. These are their privileges. Okay, so let me think that it is not my creation, but I read one of the literature. And I found this auction algorithm in economics literature. Okay, so then I brought this, double auction algorithm to my application. So how this algorithm works? How we can find the internal market clearing price between buyer and seller? The process is very simple. Now we know about the buyers or the sellers. They are prioritized based on the merit order. You can see here. This is a merit order. The buyer's bids are, stacked in descending order. The seller's offers are stacked in ascending order based on their negotiation price. Okay? The buyer's bids are stacked in the descending order. Seller's offers are stacked in the ascending order based on their. This is a price. This is a quantity. The intersection point will give you the market clearing price and the market clearing. This is there in actually. This is one of the simplest double option. You know this. Just for one color or another color, intersection point will give you the market clearing price and market clearing price. But mathematically, how you will get the market clearing price and market clearing point? This is an optimization problem. I'm sorry. So this is an optimization problem. Now, what do you want to optimize? I wanted to optimize this area. This is called social welfare. This is called social welfare. This is an economic problem. Okay, where we are trying to maximize the welfare of the participants. If you try to maximize this, then you can maximize the number of bidders or sellers who are successful in the bid. What about the people after this point? They are the unsuccessful people from the bid function. Then they have to participate in the next one. Okay, now our job is to how to maximize this area. By maximizing this, we can get the maximum market clearing price and market clearing point. So now this is an optimization problem. How we can learn the mathematics. So this is the objective function. This is the simple objective function. If you see this is nothing but area. This is minus 3 minus. Okay, now this is an optimization problem. By optimizing this, what do we get? We get the market clearing point, the total market clearing point. Okay, so now what are the constraints? The constraints are very simple. At the end of optimization, we will be getting the optimal demands and optimal scale. We will say simply optimal scale. So who are all the successful? Who are the successful sellers? And their values are non-zero values. They are positive values. Non-zero as well as non-negative values. Nobody will give a negative value. Nobody is having negative power. This is an optimization problem. Now, how we will optimize this? There are a number of optimizations. I simply use the linear programming. I use linear programming to optimize this problem. By optimizing this, I can get optimal scale speeds. Let's say by optimizing this, I can get the market clearing quantity. That is the total quantity. Here you can see this is overall optimally traded, which means I will give an example. Let us say I am participating in the double auction. I wanted to buy 2 units next day from 99. I may not be successful in the bid. I may be successful with 1 unit. It is applicable for everyone, which means if you see this graph, they are all unsuccessful people. These people are successful people. They have to participate in this. When we are trying to optimize this, more number of successful people will come in. Okay, so this is an optimization problem as I use linear programming to optimize this, and by optimizing this, I will get the optimal scale. Now there is another problem. I want to get the market clearing price. This is the price at which both buyers and sellers are trading. How are you getting this? Okay, that is also a linear programming. That we can get by taking the dual of the linear. By taking the dual of this optimization problem, you will get market clearing price. How? If you want to know more about, so this is paper. You can follow. This is the first paper in this area. I got a lot of citations, 100 meters. Okay, this is the first paper. Using periodic double auction. You may think this what is the meaning of the periodic. So these double auctions are not single auctions. They are happening at every interval. We are taking 24 intervals. We are having 24 intervals. These double auctions are happening in every interval. So that we will be having more number of successful buyers and sellers in the market. So please ensure that the power generation is utilized by the local roads and your saving economic balance is ensured. So
Not to find out, not to maximize the area. Area is an extra timing. Both sides are equal. A square will be like. So how you are going to take from D1 to B2, the calculating and then
you are saying this will be zero. No, it won't be. You can check. Okay. So that will be happening after the after the successful operation. It will be zero. Initially it won't be. So by taking the linear program, you will get the market inequality. By taking the dual element, you will be getting the market inequality. So in order to validate whether my results are correct, whether this one is outperforming with respect to the other pricing, we don't know. So in order to validate, I introduce these two incentives, sorry, indices. One is self-sufficiency and another is self-consumption. Okay, the self-sufficiency talks about where is the demand is met in the community. The self-consumption represents in-house generation where it goes in the community. Okay, you have a couple of renewables in the community. And at what fraction, how much fraction is going where? You don't know. Okay, and which fraction of your demand is met? That also we don't know. In order to represent that, I have to two terms: self-sufficiency and self-consumption. With respect to these two parameters, I will be comparing different pricing schemes, and I will say that which one is outperforming. So this is a formula to calculate the self-sufficiency and self-consumption in the community. And this is the final algorithm. This is the total energy trading algorithm where you can implement n number of pricing schemes. You can introduce your own pricing scheme and check and you can validate this. So how it works? If I already explained, I will explain one more time. Initially the market is open, the participants are ready to participate. Initially the participants will forecast what will be their day and demand generation, and that information is transmitted to the agent along with their reservation price. If around you are using game theory concept, you don't need to have any reservation price. But if you are going for the auction theoretic approach, you need to have a reservation price. That information is broadcasted to the third party agent or an aggregator. Now we will come up with different pricing scheme. You can use any pricing scheme. You can design any pricing. So for up to my knowledge, there are very few pricing algorithms using game theory and auction theory. Whatever I showed the morning session, they are all game theory based. Whatever I am currently presented now, they are auction theory based. Okay, so you can come up with your own idea. You can bring graph theory, or you can search for some other algorithm that gives proper internal pricing. Still, it is like if someone wants to PhD, this is an interesting topic where you can design a new pricing scheme. So this is X pricing algorithm that is outperforming when you compare with other pricing schemes. If you are interested, this topic is open for you. Okay, so after finding the internal prices, that information is broadcasted to all the participants via communication network. Now they will optimize. Here you can implement the demand response. You are integrating P2P and demand response. How? So using any one of the pricing scheme, you are exposed to the time varying prices. They are not flattened. They are varying custom to time. Now you can take the decisions. Now if at all you are having a schedulable loads, now you can find optimal interval for your schedulable loads. And you can apply the demand response algorithm here. I use JT algorithm to implement demand response. So now I am performing P2P energy trading while considering the demand response management. So that is the novelty of this paper. That's how I got this paper. Okay, so that is all. So this is the algorithm. This is closer to presentation. This one is algorithm presentation. I will repeat again. Whenever it is repetition. Initially, all the people they prepare their day and demand and generation. If it is game theory based, they will prepare only demand and generation. That information is transmitted to the third party. Third party will design the pricing. That pricing information is again, broadcasted to all the participants. Now all the participants, by looking at the dynamic price, they will earn their own demand response algorithm. It is up to the participants which type of demand response you wanted to use. Okay, I use demand response. Okay, after that you will have a new profile. That new profile is transmitted back to the third party. Now again new internal products will be there. That new prices are again broadcasted to all the participants. Now again the demand response algorithm is running. Again new schedule is there. This process will continue. This is a continuous process. And where will you stop? As I told you, this is how I design the convergence network. Means at some point you should stop this iteration, right? So what I did was, whenever the local load is met by the local generation, or whenever the local generation is utilized by the local schedulable loads, then stop the iteration. Okay, this is how the entire P2P algorithm it is having inherent demand response. Okay, and I have conducted few case studies. I will quickly, still we are having some. So I have taken the data from 10 residential consumers and I did this property. So there we are having one very high performance company system. So I have considered five consumers and five consumers, and they are heterogeneous by nature. That means one person consumption pattern is not matched with the another person's consumption pattern. And okay, the power generation of the renewables are estimated by estimating the weather data that was taken from the weather monitoring system. And I have considered this, utility prices. So these I have taken from the reference. It is up to you from where you want. So then I had to complete algorithm in this system. You can have a high performance computer. Then you will get a question here. If the high performance computing system, the capacity is more means your iteration time will be less. This is another, important, research area where how you can, optimize your iteration time. Means in a fraction of seconds your algorithm should run. Whatever I talk is all about day and market. Let's say you want to implement intraday trading. I want you to do the trading for the next hour, not for the next day. I want to do the real time trading, which means next hour I should schedule my flow. Whether it is possible, yes, it is possible. For that, you should have a high performance computing system. Nowadays, people are going with the quantum computers. The quantum computers, with the quantum algorithms and machine learning algorithms. Okay, they can perform the entire process within microseconds. Okay, I got on PhD this time. He's very much interested to do PhD. He has selected the quantum computing. So he's working on this topic. So I use this system. My iteration time was around 2 minutes per one iteration. So I gave this task to finish one iteration in microseconds. And that time is working on quantum algorithms to optimize the iteration time. Here you should get it out whether this computation is linear or non-linear or whether it is happening from one consumer to another consumer. Initially, what I did was I wrote a MATLAB program in such a way that first one participant will prepare a data element, then it goes to the next person, then it goes to the next person. It is like how the program is executed. It will execute line by line. Then at the end, after 10 people, then this data is transmitted to the third party. So the third party has to wait until all the people are sending the data. So then he will perform, using any one of the pricing scheme, he will find the internal prices. Then this pricing information it has to broadcast it to all the people at a time. Right? But in a program, how we will do it? But it will execute line by line. So which means the first person will receive first, next second person will receive, third person will receive, and here the demand response of every person is a sequential process. It is not a parallel process. Okay, then after discussing with my supervisor, he told me, can you, make it parallel computing? Then I'm not a computer science student, but I spent around 1 month to understand the distributed computing and parallel computing. And after 1 month, I met him. I told that I was successful. Earlier, the iteration time was more than 5 minutes. I used distributed computing and parallel computing. I can run n number of algorithms at a time, which means, as I told you, at a time 10 people will be sending the data to the aggregator. At a time, all the 10 people will be receiving the information from the third party or an aggregator. How this is possible? This is possible with the parallel computation. For this, you need to have a high performance computing system, which means your system should have multi cores. Nowadays, earlier we used to have a 2 core processor. Now 2 core, 4 core, 16 core, 32 core with a 16 GB. And this one this was having around 16 core. 16 core, that means 16 participants that can consider. 16 people will transmit the data at a time, 16 people will receive the data at a time. Though I am working on algorithm, like I came to know about this parallel processing in intermediate stage. So then we wrote a paper about whole parallel processing, and it was published in the computer science paper. Okay, so this came in between. Like people say, no, all the discoveries are accidents. That was one of our accidents. Okay, so you need to have a high performance computing system. If you have a quantum computing, then you can execute all the transactions in microseconds. If you are interested, work on quantum computing. Okay, so this is one of the case studies that we implemented. We have considered a weekday. We are having 6 days. So we considered a weekday without any demand response. Like in the last time I discussed, there are a group of participants. They are not willing to, we should do this, but yet they want to participate in P2P market. And under this scenario, this is the figure. And you see this, the community is having enough generation, and that is feeding back to the grid. During P2P, this is P2G. In P2G paradigm, so whatever the generation they are having, it is feeding to the grid. So if you go with the P2P, I compared all the prices schemes. You can see here this is SDR, MMR, DS, PD, and this is there are two prices in certain pricing mechanisms. Certain pricing mechanisms, if you take double option, there is only one price at which both the buyers and sellers are paid. If you take some of the pricing schemes, two different prices will be there. One buying price, one selling price, to maintain the economic balance. So this figure compares all the economic prices. And this one is the net demand profile of the community in this case. Here you can see that you can compare the P2G and P2 with the different prices. Now that we can observe here, there is no difference because they are not willing to initiate. They are not participating in demand response. Okay, so under this scenario, this is the representative comparison for the different participants. And here this is the table that compares different pricing schemes in terms of these two indices. Here you can see this. My proposed scheme, PDA, periodic double option algorithm, is outperforming in terms of improving the community's self-sufficiency and self-consumption. That means if I go with this pricing scheme, I can make the community as a self-sustainable. This is the second case where I am considering a gateway with a demand response. Earlier one was without demand response, this one is with a demand response. In this case, it's the figure compares the internal prices. And this one is a net demand. Here you can compare between G and P2 the different pricing. And here I don't think we will be able to differentiate, but there is a significant amount of power that is spread within the community. Okay, and this figure compares the next figure. And in this case, still the buildings are performing in terms of economic community self-sufficiency and self-consumption. So this is the third case. This is a retail day without demand response. Same scenario. See, 1.5 consumers, 6 million consumers, they are not willing to participate in the response. And now this figure is the net demand generation. So So under this case, without any other purpose, this compares errors to the location of time. Okay, in this case, still it is of common. Another case consider is the vacant day with the demand response internal parameters. And when here you can clearly observe that if you go with the P2P, you can use local generation to local load. You can make self-sustainable communities is to try the different guidance. And here you can see that there is a significant reduction for each participant. Okay, and here also the PDA is our problem. Okay, these are the combinations. So I will just give conclusion from the morning session and the session now. Okay, so I have proposed different demand response algorithm. If you are a only consumer, still you can participate in demand response. If you are a prosumer, still you can participate in demand response algorithm. So now, if you want to participate in PD, definitely your community should have both the buyers and sellers. Okay, if you are having solar, it doesn't mean that every interval will be a prosumer. Certain intervals where you are having your net demand is negative, which means your generation is more than negative. So that time you are a seller. Certain intervals there is no renewable power. That time you are a buyer. So which means this potential P2P energy trading is happening between let's say 8 a.m. to let's say 6 p.m. So is maximum 8 to 10 hours. That's not more than that. So if you can potentially use your local generation to the local loads, then you can create a self-sustainable locality. And you can reduce your energy bills significantly. And here you can see this. This is a 10 to 50% of the community electricity is reduced. With the different prices, in this range, your bills will reduce. Any doubts so far? So whatever I have presented now, it is a combination of two papers actually. In one paper, we presented average pricing agreement. In another paper, we presented only the level option. In another paper, we presented comparing all the pricing schemes. Any comes so far? The morning session and the second half, there are only demand response algorithms and P2P energy trading algorithms. Okay, in order to manage your renewable, or you can say that in order to manage the local generation, that is presenting different algorithms for the energy management. Okay. So I want to introduce a new concept, the concept of blockchain. If you see this figure, whatever I have discussed with you, let us imagine there are a group of buyers and sellers in the community. There are a group of buyers and sellers in the community. They are participating in the bidding or auctions. You need to have a central party or a third party to facilitate energy trading. Otherwise, who will take care of this? Bidding. Someone should be there. That's how auctions works, right? Some third party agent will be there. He will facilitate the energy trading. So this is a centralized market. This is not a decentralized market. This is a centralized market where there is a third party who is facilitating this energy trading. And there is a problem. What is the problem? This third party has all the incentive to tamper the data. Let us say this group is participating, these two groups are participating in peer-to-peer. I am the third party. My sorry is there. I want to use it to pricing. I have the data, you don't have any control on my pricing scheme. I have all the incentives to tamper my sales data, and I will provide more income. You cannot see just by banks. All the banks are central banks. What is happening? Their transactions you cannot see. What you can see is you can see only your transaction. What they are doing internally, only the employees can see. That is the centralized system. There are problems. That's where people came up with this idea of blockchain. It started a long time ago. You might have heard of cryptocurrencies. There is an imaginary person with artist associated who introduced this blockchain running on a P2P network. Basically, what is this blockchain? Basically, blockchain is a digital ledger. You can imagine simply right, it is an Excel sheet. We know Excel sheet, right? It has the rows and columns. Imagine that one person is fulfilling some details in a row wise. The second person is filling second row. Third person is filling the next. Simultaneously, people are updating the row. But whether the other person can change the other person's data, it is possible. You share your Excel sheet, you upload the marks. You can change the marks of the other person. Let us imagine a shared Excel sheet where you can only feed your information. You are not able to change the data of others. Such a ledger is the blockchain. How you will create a block, how you will validate that it is too much information, I don't want to give too much information. Just I want you to talk in terms of a superficial way. So blockchain is nothing but a shared ledger. Or if I want a definition of a blockchain, blockchain is a decentralized distributed append-only ledger technology where people will append the data and these data or transactions are stored in a blocks. These blocks are validated by the miner. And once the transaction is successful, it is updated in the blockchain and the data will be there forever. Every person who is connected to the blockchain network can see the data, but you cannot tamper it. If you try to tamper it, it is visible for all the people, and they have to validate your data. If someone finds it, it is tampered, your transaction is not successful. That's it. I don't want to go deep into that. So what it does, basically provides the security and it is immutable data. Someone cannot tamper it. Now, how we can bring that blockchain to our system? Here we have a problem of third party. Basically, the blockchain is used wherever the third party is. Take an example of healthcare, or take an example of land registrations. Everywhere third party is there. Best example is there, land registration. We have to depend on the third party for our, land registrations, and we need to pay him. We need to bribe him. We will bribe some of them. Okay, and that's how it goes on. And the data is not available in the digital form. Okay, so blockchain is basically used to solve the double spending problem. Now, what is this double spending problem? You take an example. Let us say a person. A has 1 rupee in his account. He wants to send 1 rupee to B. He has sent 1 rupee to B. Okay, and he wants to send the same 1 rupee to other person. It's a digital one. Okay. Imagine he wants to send 1 rupee to B and simultaneously. Which transaction will be executed first? If it is sequential, the first transaction will be successful. Let's say if it happens, the 2 transactions are simultaneous. How it will happen? So this is the double spending problem in terms of the finance. Okay, it is a double spending problem. That's where the blockchain will be used. And another problem is banks are running with our own money. Okay, they are getting a lot of money because of our deposit, our loans. They are getting crores of money. And in order to execute multiple transactions, they are charging the transaction fees. So to avoid this, group of scientists they develop this blockchain. And why third party needs to earn a lot of money. And that too, whatever they are doing is not visible for us. It is not our side. What they are doing, nobody knows. Okay, that's how some of the banks are collapsed. You might have heard about the Lehman's in the US. Their banking system is collapsed. Then I think it was in the year 2008. Then onwards the blockchain came into the picture. That's how the cryptocurrency, Bitcoin came into the picture. Okay, so now when it comes to our problem, we are also having the third party. He has all the incentive to convert the data. Now, if we can use the blockchain here, we can solve the third party problem. Now, who will facilitate the trading? Okay, this is a centralized market. Now we should know about a little bit about the blockchain, how it works. This is the present electricity market. Looks like complex, you can imagine that. Our electricity market is a vertical market. There is a generation, there is a transmission, there is a distribution. They are under the monopoly of the government. Nobody has any control over this. Government has all the control. And there are consumers. The power supply is coming from top to bottom. Okay, money is going in the reverse direction. Okay, this is single direction. It is not bi-direction. The data transfer is not bi-direction. Power is coming like this. Okay, most of the times, and money goes in this. And in between there are so many third parties also. Even in wholesale electricity market, third parties there. Even in the retail market, third parties are there. So if we can use the blockchain technology to solve one of the problems, okay, that will be, it will liberate the electricity market. Okay, so this is the present electricity market. It is a centralized market. It is under the control of the government. So this will be the futuristic, electricity market. Wherever the third party is there, replace that with the blockchain. Wherever the third party is there, replace with the blockchain network, and the data is visible for all the nodes. Okay, all the nodes can see what is happening in the network. Okay, this will be the futuristic electricity market. Now, what is blockchain? No, I will do a compare. So that will train. If you have a historical data, you will train. That's how you will the new population.
Even artificial intelligence to collect each and every neuron, the other neurons. So the same thing in previous.
You can visualize that, but there are there's a major difference. All the neural networks they will work based on the training, how you train the data from the different nodes. Blockchain network you can visualize that the nodes are there. The data is visible to everyone. Now, who will facilitate that? Any one of the nodes will facilitate that. You can imagine the blockchain network. So, earlier you see this figure. There is a third party which is facilitating. Now, you replace this with the blockchain network. Okay. This will come to any one of the nodes. This fellow can facilitate the data. This fellow can facilitate. Anybody can facilitate. And this data is visible for everyone. Okay, they can see it. They are only simply replacing third party data in blockchain network. What is blockchain? If you can learn okay. As I told you, don't think the blockchain like very complicated. You can imagine that is a data structure. Simple way to put it. The blockchain is not blockchain is basically a data structure. Okay, this is a distributed data structure. This is a centralized data structure. This is a decentralized data structure. The data is there in every node. The person in the corner is there. Okay, whoever is part of the network, they can see what is happening in the network. Okay, so what are the applications of the blockchain in the electrical industry? These are the applications. P2P energy trading, demand response, digital integration, EV integration, wholesale electricity market, grid management, whatnot, wherever the third party, wherever they need the security, you can use the blockchain. I use the blockchain to implement peer-to-peer energy. I'm not a computer science guy, but I know a little bit how the blockchain works. And I have written a smart contracts to facilitate P2P energy trading. Okay, these are the different applications. If you are interested, you can do masters or PhD in this. Okay, you can find any one of the application, get a PhD. Okay, so how it actually looks like? The same application, but we are going to do peer-to-peer energy trading. So that I replace with the decentralized market. How? You see this. This is a community. They are all having. This is a physical network. They are having the smart meters. These smart meters are connected to the blockchain network, and this is a blockchain network. And where the blockchain is there. I told in the last in a centralized market, there is a third-party market operator who is also part of distribution network, or he can be an independent system operator. I have presented a development. That development algorithm I am running on the virtual layer of the blockchain network. So my job is done, and I can be able to perform decentralized peer-to-peer. Okay. In earlier case, whatever the energy trading is happening, that information is there in the third party. Other participants they cannot see. But here in this, you can access the data of the smart meters and you can visualize. You can see the data in your smartphone. How it is traded, or let me put it in this way. I have buyer. You are a seller. I have all the rights to select other sellers. I can select the sellers. If you are a buyer, you can select the seller. If you are a seller, you can select the buyer, which you wanted to buy. So that information is clearly visible in the blockchain network. Is that clear? Am I making it clear? This, I don't want to give too much information regarding blockchain because that's my bread and butter. I don't want to give too much information because I'm working on it. Okay, so that's about decentralized P2P network. Any doubts so far? You can ask me. So with this we go on my P2P. And the same one here replacing the quantum computing. Any doubts? No doubt. Then we will, if there are no doubts, we will go for the lab session after 10 minutes. Sir. No doubt. See, after the post lunch, it is very difficult to see the drawing.
Sound colors
Such a
in the lab. చిన్న ఫిల్ స్టేషన్ ఉంటుంది ఇక్కడ ఫిల్ స్టేషన్ ఉంటుంది ఇక్కడ
I'm expecting so many questions. Nobody's asking. So many people are working. It's not that whenever I was very much fascinated about the cryptocurrency and blockchain, how it works. I started reading a lot of articles regarding the blockchain, how it works. I will learn very little. Okay. That time, very few articles were there about this decentralized energy. Now, if I search, n number of articles are there. But still, it is a buzzword. If you talk to someone about, I'm working on a decentralized, P2P energy trading using blockchain and integrated with the machine learning, it sounds like what is like big, but if you go deep, it's very simple. Nobody's having any doubt.
2 minutes లో lab.
After this, there will be a tutorial session where you will be, if it is possible, write your own MATLAB code. If you are unable to write a MATLAB code, we are already giving a MATLAB code. Just have a look, observe what is happening. Whatever the demand response I have presented in the morning session, the same thing is converted into your MATLAB code.
Participants, from 3 to 4 we will have lab session at CCC lab, opposite to missions lab, ground floor. Again, all of you will gather here at 4 o'clock again. Some customary practice is there. Then after that, if you require, you can practice in the lab from 4:30 onwards. So I will explain lab session from 3 to 4. We will go to
సతీష్ సార్ ఆఫ్ చేయాలి కదా రికార్డ్ అవుతుంది మీరు మాట్లాడేదంతా ఆఫ్ చేయాలి కదా మీరు